Shut up. So we have two equations. Equation B is AR cubed plus AR to the 4 is equal to 180. Now I can also take out something there. And what I can take out is AR left with R plus AR squared. There's no need, but so these two equations, I can work with these equations, or I can work with these equations. Alright? This is just the same equation, it's just in factor. AR squared times R gives you AR cubed, AR squared times R squared gives you AR to the 4. Understand? Just drag out, you factorize that. That makes sense? Here A goes in here once, A goes in here R. So now I have these two equations. And since this is a GP, and you are working with common ratio, it means you are going to have to divide equations with each other. So you will be saying equation B divided with equation A. Ultimately, it doesn't matter which equation you write first. I just don't want to really, it's only up to you. What I'm saying is you can say equation A divided by equation B. Because our objective here is to calculate the first term and the common ratio. So we are looking for A and we are looking for R. The moment you are looking for two things, it means you are dealing with simultaneous equations. Is that the same thing it was telling on last time? Before 1-4. Asking. I'm still supposed to push my phone and the insurance. Is not the other one of this? Now why is your mouth book? You are again displaying ivory here. Anyway, let's take equation B, which is AR squared over equation A, which is A 1 plus R equals to 108 over negative 4. Are you here? The whole equation B over equation B.
What is this?
Fourth term, AR cubed.
Yes.
This cancel. You understand? How many times does negative? Can we do cross multiplication from here? So I'm going to have 108 divided by negative 4. 54, 28, negative 28, am I right?
27.
27. There's a reason why it's a cube number. So I can work with that. R squared, R plus R squared.
Yes.
Actually comes from this too. So far so good.
That's messy.
So far so good. I'm asking.
Let me see.
This question was it the first term plus the second term? Does it show for me quickly?
Yes.
It's the first term plus the second term.
Mm-hmm.
A else n 1 plus R. And this one was the fourth term and the fifth term. Just making sure. Maybe we can bring in some sort of cross multiplication. But do you realize something there with the top one? The top one. We factorize it wrongly. Yeah. Because what is here should be there. It's where is it? It's here. But it's coming from AR cubed. Thank you very much. AR cubed is a common factor. Then it goes there 1 plus R times. Does that make sense? Yeah, that is what I was looking at because I know that this numerator and the denominator, this is supposed to cancel out. So here you have r cubed and then 1 plus r. So basically, these two here cancel. So we're left with r equals negative 27.
Cube.
R cubed, sorry.
Which is
the
3.
cube back. So now you take what?
R equals to
We get
negative.
r alone,
Negative.
you take the cube root. And the cube root of a negative number exists now. So it's going to be negative 3. So now we know what our r is.
Yeah, no.
Therefore, r equals to negative 3. So, if we go back to our formula,
Need to factorize.
we now going to put any term that we have. We are going to take that and put it back into any one of our two equations.
Right.
Either equation A, okay, that means we can put it back in this equation in order to find the value of A. We put our value here. Or you can put it in this equation, but which one would be best to do? Which one would be the best choice?
First.
As already. You see, we know what our value of A is now. Is it better if we now have to go back to the original equations? Either one, this one or this one, right? Should we put it R here and here? Or should we put the R here in order to find the value of A? It doesn't matter. You get the same answer. But it's best if you know, the one with less squares and cubes inside. Okay. So we're going to substitute R equals to negative 3 into equation A, which happened to be A open bracket 1 plus negative 3, which equals to what? Negative 4. Now, inside you have negative 2 here. This is negative 3
Negative
plus
3.
1, eh? So this is the same as,
Negative
that's what that means, by the way. So then
2.
you
Positive.
divide through our power,
Negative 2.
therefore A is equal to.
Positive.
So we now know what our R is, we now know what is our. So when you ask you now to write down the first three terms, then you can go on.
3 the
A would be 2, then you multiply that.
I 3 and then the square.
Makes sense? But is that working? Or otherwise we don't need to. Is it not too far? What did you put last time? What's it covering now?
It's too far.
It's too far. The board is too small. You need to move it. I don't know, you need to cover this general area again, not a big deal. Because last time, the board has to be something like that. Camera lane.
Music video. It's a music video.
So what are we seeing right now? No. Are you seeing this? Anybody do that?
This is easy.
Shit, I'm here.
Because last time it was cut in half.
Yeah.
Can't move my phone. Are the kids bringing their phones to home?
That's what they asked me.
So why not?
Yeah, I must. It's a fun day.
No, I'm just asking why not. I'm not saying we'll change. I'm saying it's the mindset. Kids will bring their phones. You guys are also something else.
But it's a fun day. You're supposed to have fun. Videos.
We're just waiting for Mr. Bradley. He knows his job. But lazy. Okay. Thank you, Mr. Bradley.
Video.
Then, is there a similar question like this in your book? Something that says weeks exercises. Check it out.
Just in the
Before we go to sum of the geometric and arithmetic sequence,
seeds.
nothing.
Yeah.
Ask this guy. This guy is in the middle of the check what you did.
Huh?
Already. Pick up.
I'm joking, I'm doing.
You want to do concept.
My foot has been
You don't want to eat it.
no
You already made one of them that you go.
So,
You did not say that. Did you want?
a similar question. Is that just A, B?
When I was in GBs, go to GBs, right?
Yeah.
Before sum to
Next one is sum of geometric series.
no problem.
We are not there.
We're there after this.
Yeah.
Let's continue the same exercise.
You can go to the next exercise.
Okay. You can find, let's do two more. So question 5. Find the first three terms.
Easy. So.
I'm just going to write GP. Isn't it? They say, I don't know, this one is developed fact. Okay, first thing is, they say with the first term is what? 4. And the common ratio is what?
Negative 3 over
Is negative 3 quarters.
quarters.
Isn't that so? Right? So you're supposed to find what? The first term.
And the second term, and the third.
Is it the same question? So let's just
the
do
first, second, third. So you say 4, and you say 4 times. The other one
or find the first three terms. No, it's different. You said this is the first question.
Yeah, this is just the first.
There's going to be still the same instruction. Yeah, that's why I want to solve this one and maybe just do one more. I want to straightforward. So this is a general formula for the nth term. So they are saying the first term is 4.
That's already the first term.
And our R is what? Negative 3 over 4. That's our ratio. Right? So that's n minus 1. So the first term would be t sub 1 equals to 4. So this is just you calculating when you get that value. T sub 2 equals to 4. Negative 3 quarters, 2 minus 1. T sub 3 would be 4. Negative 3 over 4, 3 minus 1. Right, what is the answer here?
4.
4. Right?
3, 4.
What is the answer here?
Negative 3.
It's the same, negative 3 over 4.
They cancel.
Cancel. This is negative 3. What is the answer here? Square. So it's 9 over 4.
2.25.
Yes.
2.25.
9 over 16. 4 goes into 16. 4 times. 9 over 4? Final answer.
2.25.
9 over 4.
2.25.
Okay, but you should see that the sequence is
Yeah.
decreasing because you're multiplying or by a ratio which is a fraction.
Oh, so
You understand?
even
This
low.
is less than 1. Now, if the ratio is a negative number like this, your sequence will be a positive term, a negative term, a positive term, a negative term. It sort of oscillates like that. Why is that the case? Because if you have to write it down, the first term is 4. The second term is negative 3. The third term
So anything,
is positive 9 over 4.
anything,
And so on, and so on.
anything squared.
So you're multiplying this was obviously by the common ratio, which is negative 3 over 4. Then you multiply it again by negative. So the negative times the negative gives you that positive, and so it goes.
Yeah.
It's a very important concept to understand when you're dealing with the ratio being negative. And sometimes you're going to get questions where the ratio is now the square root. And if the ratio is the square root, remember there are two possibilities. There's a positive square root and a negative square root. So I'm talking about instances where you are doing some calculation, you are ending up with something like this for R. Then you can basically then create two sequences. You follow? Where one sequence will have a ratio of 2.
Is that another question?
Yeah, like the one in the previous.
Yeah.
But if it's cube or odd root, first root of 32, that is only one.
It's 34.
Does that make sense? Okay. So I'm not going to do the rest, but maybe D. I like D as well. So it's the same instruction, find the first three terms. They are saying the first term is what? Square root of 6. And the common ratio is what? You're cool. Square root of a half. We are supposed to try the first two terms.
First term 6. Square root of 6.
I have to shoot. No, I don't. But yes, these sweet things. Anyway, T sub n equals AR. You are not getting marks rightly from it, but it's helpful to do so anyway. Our A is square root of 6. Our R is square root of a half raised to that. This is our T sub n. This is our general formula.
In general.
The square root of a half is a natural number. So we're going to leave it like that now. So the first term, again put 1 and 1 here. So the first term is going to be square root of 6. Well, if you put 1 here, that's going to ultimately make that 0.
Yeah,
So that's the first term. Does everybody understand why that's the first term?
it's even in the question.
Even in the question it says that is the first term.
Yes.
Then the second term will be this, and whatever that is, 2 minus 1. So anything raised to the power of minus of 1 is equal to that thing there. So that's square root of 6 times the square root of a half. Now, just so you know, square root.
Square root.
I hope you remember from
So it's
indices that if you have 8 raised to the power of x times 4 raised to the power of x, you multiply the bases, you keep the indices, so this is 32 raised to the power of x. You understand? So using this reasoning, we have the square root of 6, which is 6 raised to the power of a half. This is what this is,
times
right? Times a half raised to the power of a half. Are you with me? Ultimately meaning 6 times a half, keep the power of a half. And a half of 6 is what? 3 raised to the power of a half, which is therefore the same as square root of 3.
Gracias.
Don't work with decimals. Don't work with decimals, mess up here and mess up here. We have done search for a reason. You understand?
Just continue, but it will give it.
Yeah, again. When you are given the nth term, that you are supposed to find the first 3 terms, like you see that part C, find the first 3 terms of the GP
Just substitute.
with the nth term.
Just substitute then.
You substitute in what?
In the end. Where you see it.
Same instruction. Find the first 3 terms of the GP with the nth term, this one, the nth term, this stuff equals to. You follow? Equals to what? 7.5 raised to the n. So this is our formula. When 7 is the first term, this is the nth term, right?
7/2.
This is the nth term. But he is already given to you like that. So this actually is the same as 7 raised to a half n. That's the nth term, that's the rule. But the rule is just that. You follow? It doesn't conform to what we know as n minus 1. This is still a GP. And this is the rule. Rules for geometric progressions, this is standard form for it.
Standard.
But whatever we put for A, for N, for 1, 2, and 3 is still going to give rise to a geometric progression. So the only thing you need to do here is when N is 1, when N is 2, when N is 3. So we've got 7.5 raised to the 1 power, that's just
7/2.
half of 7 halves. You have 7 raised to that 2, that's 1/4. 7/4. I hope you still
Yes.
you get to where the 4 comes from. 1 times 1 is 1, 2 times 2 is 4.
7 over 8.
1 times 1, 2 times 2. Final answer. You see how I do it? You see how I do it?
Yes.
Okay.
Expand.
So if it's now 3, 7
over
a half cube. 1 cube is 1,
8.
2 cube is 8. So 7 over 8. And so on and so on. If you like decimals, you can go ahead and do decimals. Okay. First term,
Easy
7
grade.
halves, 7 term,
1 more.
7 quarters, third term, 7 eighths.
3 more.
Is that right? That's the easy. So when they are telling you the answer is this, you use that. It's just a general formula.
Like those questions.
You follow? What is the question?
It's just that.
What is the common ratio here? Whoa. Keep quiet. I told you an advert for Colgate. Mr. Bradley, what is the common ratio here? It's a half. What is the first term? The first term is 7 halves. What is the first term? Don't confuse the 7. It's just part of the formula. You understand that? The general formula of a GP is yes, that. But now you're given an answer. That's not the formula. You're supposed to use this formula. But you can't go just because it looks like that. Now you're going to assume that that is the first term. No. The first term is 7 halves. You see why I'm asking that question? First question looked like a seemingly very easy question. But then, can we safely say that the common ratio is a half? Because you were laughing at him. So let's make sure, right? So let's make sure by taking term 2, we divide by term 1. The second term, which is the 7 quarters, we divide by the first.
Just multiply.
Are you with me? Are you with me?
Multiply by 3.
Mr. Bradley, this becomes 7 quarters times 2 sevens. Mr. Bradley, 2 quarters, so it appears that you were right. That the ratio is half.
It's obvious.
No, it was not obvious when I was asking what is the first term. Was it?
Yeah, but first time.
Never ever.
Assume.
Yeah. Why that is the case? I am going to leave it to your imagination. Now you might be one, but I am not one. So don't make a out of you and me. You get it. He still doesn't get it. You don't get it.
You can see, sir. We are live.
I'll cut that part out.
Let's continue.
Can we go? Oh, breakfast too? You're not understanding. Huh?
I don't get it, sir.
You do get it. Let's not say that we're alive. No. Stop singing that story first.
To get the views.
What is that? Are you getting it first? Yeah, I should get it. I always said it in class, yes? Oh, okay. Just don't look it. I know who uses it at home also. Small brother. Giving the stress. What's your hobby?
What time are you practicing?
You must like fasting.
260.
Question 8. Yeah?
Volunteer.
Come.
I like it, man.
The first 3 terms of a GP are, I'm going to write it down for you. But it's supposed to be in brackets then. It's better if it's in brackets, then you don't make a blunder. So that's the first term, the second term, and that's the third term. We are told that it's a geometric progression. Find the values of the first 3 terms.
Straightforward.
Right, so I think step by step. First identify your A, then identify your R, and then you continue from there. Too sweet. supporting these funny things.
Sometimes.
No wonder he doesn't want to play in Caribou.
The sky is the limit.
What are you doing right now? No, those things that you're making. Ah,
They get the idea.
are you sure? P times P? No one.
It's okay, sir. It's okay.
Go on first, this side.
Okay.
Then so
I'm
on.
just showing you. Negative, right?
Yeah, what is 12 times 4? Idiot?
So
What is going to say these things? It's 48.
we are alive.
You're not lying.
Let's see those things.
Why are these words cancelling, as you are saying?
Once you take it over.
Same thing equals the same thing, the signs are the same, they change, it's going to obviously give you zero.
Yeah.
So you left with 1.
So we just get something. So let's go.
12 minus 4 is what?
8b positive 8. Equal to positive 8.
Good. Go the other side. Okay. This is where you're going to ask me where, how many times is 8 going for the 8? Are you for real right now? You don't believe in your own abilities. You see, it's because you are supporting this with this.
Are you sure?
AS level does not know what is 4 times 8. Now, what are the first 3 terms? Write it down there. Which is?
Plus.
It's a plus all day long. So write it down there.
Okay, so what?
Should I kick it now or later?
Yeah. Standard procedure.
Did you hear that?
Supposed to find
It's kind of very simple. The first 2 terms.
like the young divide here.
And by the way, what is R? Just look at it. It's 3, boy. What is half of 6?
I said please.
No, you didn't say nothing. You're explaining. Advertising ivory in the jungle.
Please.
I think it's time.
The question didn't answer. Stick to the question.
Question 10, the last one.
Standard procedure.
Volunteer. Connie,
Let me
you
do
want to
that.
volunteer?
Let me do that one.
No.
Please.
Too soon. Too soon?
Yeah.
Oh.
So let me do that one.
Alright, I'm just going to write it down. It says the first 2 terms. No. It doesn't say the sum, eh? First term is 3. And then what? The second term is what?
6.
And then the last term is 768, and we are still doing a geometric progression.
Let me do that one.
Find the number of terms. Come.
I like this.
You like it?
I
No?
like it.
You're gonna walk today. Up and down.
I'll do it here.
No, it can fit there. It's not a very big question, man, isn't it?
Yeah, so I don't need to write the formula. I get the idea.
Okay, but what does the last term tell you?
It's up and it goes to the last.
So the last term becomes what?
It's up and
So this up n is equal to the last term. So when you're given the last term, that last term becomes equal to this up n. Right? You still remember what I said yesterday? If you are told that for the following geometric sequence 3, 6, dot, then you give the last term. The last term is, and then you want to find how many terms are there, and you take the last term and you to your formula. So you still have to definitely find your R. The A you can see already, A is 3. R is 2. So from there, you continue. Now, one of the things that I just want you to be on the lookout, just wait before you continue. One of the things that I want you to remember, we're working with a geometric progression. And we want to find the number of terms. Now, the nth term of a geometric progression, the nth term of a geometric progression, when you are looking for this one, is the one that is missing. It means you will deal with either indices or you have to deal with logs. You understand? Because what you're looking for is that power. And because you're looking for that missing exponent, it involves probably exponential equations, which you can find because 256 can be written as a power of 2. Alright? Trying to make the bases the same and only equating what? Indices. Otherwise, if that cannot happen, then you need to be able to introduce logs.
Take for sides. I can even take logs, but
no need. So 246 is 2 raised to the power of 8. Okay, so I think you can continue here.
yeah.
Make a little box here. And how do you find 2 raised to the power of 8 with your calculator?
Sure.
You can find it with your
So
calculator.
that says,
You know the fact, but so you have been watching a lot of the videos, right? So 256.
I'm promoting.
Yeah, you are. Sure.
Huh?
So sometimes if that is not the case, then we have to bring in logs.
I'm dancing.
If you are supporting this nonsense thing, please.
Promoting, I like. Shout out to someone.
Come, let me give you a reminder. So the world can see. Come on, man. Let's give them what actually happened in this class. It will not be a hard one. It will just be. I hope I don't have this red and yellow thing that you guys are doing on the stuff that you're doing.
Yeah.
Because right now, this part of it looks like these people are doing tongo. Okay, so that means we can start with the sum. Alright? Because I want to start with the sum and okay. Start with sigma notation. I want to start with the real bit. This is just revision, but it is there. Alright? Okay, so arithmetic and geometric series, the moment we refer to hello. You know.
Come on, boy.
Come on, man. What's wrong with you, man? I know. It's not very easy.
Don't do
See?
it.
Did you see that?
Yes.
It was really difficult. Not easy.
And this is
What did you want to do? What did you say?
nothing. I'm just here. The next question.
I wonder if Giovanni is like 30 years old and he drinks a lot of alcohol. You probably won't hear anything coming up. Are you such a problem, this one? Ah? Are you fine? Ah? I don't know how the book is. Maybe they are mixing them. So we are going to deal with the formula that we now should know. We should know that the nth term of a arithmetic progression is given with that. The nth term of a geometric progression is given by that. We are now focusing on the sum. That means when you are given the sequence, you are now adding the terms. Okay? And the sum of a arithmetic progression is given like that. But remember, the L is the last term, which is actually equal to
T sub
T sub n. which is actually equal to what? Maybe I should not put it here. The nth term is the last term, right? So that means there must be then another formula that we can use if we have the first term and we have the last term of a sequence. Then it assumes, right? 3 plus blah blah blah. And you have the first term, you have the last term. Then it's handy to use this formula if you want to find the sum of maybe 20 terms or 10 terms. Yeah? Yes.
So we thought of this formula.
Okay. We don't have to prove it now, but it's actually a very interesting story. Okay? But I want to move on. It's a very good thing that you're asking. Maybe you can also do some research. Maybe you want to write some sort of a thesis one day. But very interesting. So we said that the L stands for what? I'm just writing T sub n there, so you can still hope you still remember that. So then it's going to be, and our T sub n is nothing but what? A plus n minus 1 d.
Like them.
Now if you clean that up,
I see like them.
you see like terms? You have got 2a, because a plus a, then plus n minus 1 d. So these are then, this is the sum, or that one is the sum.
The general formula.
Okay. So let me just write the other one. So this would be the case for what? Arithmetic progression. For geometric progression, so far we have the nth term, the rule that connects a sequence, and if the sequence is geometric. And for a sequence to be geometric, you know that it must have a common ratio as well as the first term. Then S of n is calculated. There are two ways, but ultimately it doesn't matter which way you write first. Okay. A outside, 1 minus r to the n.
R should,
1 minus
R should be less than.
R
Should be less
should
than.
not equal to 0. I mean to 1.
And it should be less than.
R should never equal to 1 because if R is 1,
Should be less
the
than.
fraction becomes undefined.
Should be less than.
Understand? But in this case,
R
it
should
ultimately doesn't matter
be less than.
whether you use.
So I want to know why.
Whether you use this formula or that formula. But we just like to say if R is a
Yes.
fraction,
Less than 1.
we prefer to use this one.
Less than 0. R is greater than 0.
Like if R is, for example, 0.5. You understand? Then it's easy for you to say 1 minus 0.5.
It's easy.
Then you don't have to deal with some negative issues.
Yes.
But please don't let this and that should be exactly identical. The only difference is that one has got the power. And also one of the things that I keep on seeing, it's basic errors but they happen, is that people write R and N here minus 1, thinking that minus 1 belongs here because they get confused here with the nth term. Don't do that. Né? And for this one, if this R is greater than 0. But remember, R cannot equal to 1. Otherwise, it will flatline. It's not so. Right, so this is the formula to find the sum when you are given a sequence. For example, the very first one, a very simple one. If the question says find the sum of the first 30 terms.
You're not given the last.
Yeah. Of the GP, is it a GP? Okay, you have to do it.
Exactly. So I think it's
You think so? 3 plus 8 plus 13 plus and so on. So there is no hints in the question. You're not being told this is a geometrical progression. You're also not being told this is an arithmetic progression. So you cannot just use any formula. You first have to determine, is this a geometric or a arithmetic progression? So let me test for an AP. And when you test for an AP, there should be a common difference where you take the second term minus the first term, for example, which is equal to the third term minus the second term. Now, if we take the second term here, you get 8 minus 3, which is 5. And then here you have got 13 minus 8, which is 5. So therefore, we are dealing here with an AB. We are not given the last term because it says and so on and so on. It doesn't go and so on and so on, and then it gives you plus the number.
I don't know.
So we want to know the sum. We don't want to know the number of terms. This is not what this question is asking. Do you understand?
Yes.
How will you know the number of terms here if this is continuing forever? Before. We just want to know the sum for the first term. Unless, let me repeat what I just said, because I just realized I made a huge mistake. How many terms does this particular sequence consist of? What we are supposed to find the sum? It consists of 30 terms. So what I'm saying is, if these formulas are foreign to you, you can go and add 3 plus 8 plus 13 until you get to the 30th term.
General.
Another question. The 30th term will also be our last term. Do you agree?
Yes.
Which will be our T sub n.
Yes.
Now, let me suppose I'm not jumping into the formula, right?
Yeah.
Let me suppose I find the 30th term. So, what would the 30th term be? Do you see which formula I'm using? I'm using the nth term. That will tell me that particular term. So, the 30th term will be, so again, it is 8. What is the first term?
3.
And 30 minus 1. Now, we calculated the common difference, which is 5. So, this is telling me what will be the 30th term. So, here you have got 29. Alright? And 29 times 5, don't worry about it. 145 plus 3. So the 30th term will be 148. So that means if I continue with the sequence, plus, 85, 85, 18, until I get to 148. Huh? Now that I know what the last term is, for example, I can now use the formula where the last term can be used. So I'm looking for the sum of the first 30 terms, and the first term is 3, and the last term is 148. Half of this is 15, and 3 plus that gives you 150. Is there something you want to say? Mercedes? David Lee, head girl? Are you fine? Where were you lost right now? But that 3 comes from where? It comes from the sequence, which is the
2265.
according to somebody here, this is 2000 what?
265.
Do we all agree with this answer?
Standard.
Right, but if you did not want to do this, in fact, I'm just doing this just to bring that like the third term or the last term. If you have the last term, you can calculate the last term. In this particular case, the last term will be the 30th term. Then you can use that. But ultimately, for the purpose of this question, we're supposed to use this formula here. Do you understand that? Where the sum of the 30 terms is going to be a half of 30 and 2 times 3 plus 30 minus 1 times 5, which is the common difference, and all of that should give you exactly the same answer. Does that make sense? Okay. So, although you might have a question that deals with the sum of a series, there could be instances where you will be asked to find maybe the fourth term or the last term. And you're dealing with that, and also maybe the S sub n formula, and there will be instances where you have to find the value of A and the value of B. Because the S sub n formula, right? At the nth term, they both have that D in them. So we can create simultaneous equations also with this scenario. Where you can be told that
So this question.
the
fifth
sum, or you are told that the fourth term is that equal to that, and the sum of so many terms equal to that. Then you use them simultaneously to find A and to find D. You follow? But you must never forget that when questions are given, you must first determine whether you're working with A, B, or B. And there's a very quick thing you can test. Subtract successive terms, see if there's a common difference. If not, divide successive terms, see if there's a common ratio. If that is the case, then you're obviously dealing with a common over a GP. Right. We should try faster, man. Here he comes.
Basic.
What is 12 minus 8? We're just checking, you know, because we've got somebody special. Alright, so the way the book is set up, the first few things here is the sum of the AP. Go to page 56, please.
Already. Jumping the gun.
Yeah, the stuff is exactly what I was explaining. Yeah, the next part is now explaining the last, if you're doing a sequence plus plus and then the last. I don't
So it just
a
substitute.
question on something that I also. Try now 16. Question 3. Page 56. Right. How many terms of the AP? There's the one. The one that has a must be used to make the sum of. Right.
Standard.
What is the AP? What is the sequence?
100.
100 plus
94.
94 plus.
88. Plus total.
How many terms of the AP must? They use the word used, but it should be added.
Added.
But if they say added, they are giving you
The
a
English.
hint.
The English.
They are giving you a hint.
Yes.
Because the moment we are talking about adding terms, we are talking about what? The series. So then you might remember which formula to use. So I'm just going to go with that must be used.
This series goes to infinity.
But also, this word is also another hint. Sum of what is the number? 500? 500? That is S sub n equals to 574. How many terms? It means n is the missing one. Okay? Do we have our first term? Yes, our first term is 100. What else do we know? We know this is an AP. So if it's an AP, there's a common difference of 94 minus 100.
Negative 6.
The common difference should be a number that is negative because the symbol is
Negative
6. So now we can actually punch that in and see what we have. So we have got, we can't use the formula for A plus the last one because we don't have the last one. Okay? So we're going to use n over 2. You follow? Because we're looking for A. 2 times A, our A is what? 100. Plus n minus 1. And our D is negative 6. To give us a sum of 574. So from here on, it's just,
Quadratic.
it becomes a quadratic, but it's totally up to you how you want to do. So let's first do the stuff inside the bracket, okay? So this is a 200 here.
Yeah.
And then if you multiply that gives you a 6.
Minus.
And obviously you multiply that gives
Minus
you
6n.
a minus 6n.
Yeah.
And then you are going to get 206 here minus 6n equals 574. So you can multiply both sides by 2.
Yeah.
Alright.
1,150.
Which is maybe something that you should think of. So multiply here by 2 and you multiply that by 2. So that the 2's cancel, leaving you with this business here. So this is 1,000.
184.
Can we trust this answer?
Yes.
So it becomes quadratic. Now, what else can you tell me about looking for the values of n? Can our n be a negative number?
So forget.
Can our n be a negative number? I'll come back to your answer because you gave me the wrong answer.
Sir,
Can our
you
n
just
be a negative number?
No.
Because n represents how many
Yeah, cannot be.
things,
It cannot
how
be.
many kids are in the class.
Yes.
Can't have negative kids in the class, no?
Yes.
Right, so sometimes when you are solving something using a quadratic equation, you might have two answers, and then you have to disregard the other answer if it doesn't fit. But it doesn't mean all the time, so you have to do the stuff and actually get to the answer, right? So that is going to be minus 6n squared plus 206n
I see what
minus 1148 equals to 0.
I see what you did.
And something else that you should know, that if a number is divisible by 2 and by 3 at the same time, then 6 can go in that number. I hope you still remember that.
Yeah.
2 goes here 103 times,
6 will be.
3 goes here. How many times? Don't worry about it.
3 doesn't. 3 doesn't.
How many times is 3 going to 20?
Only in 20. But it goes 68.1. So 3 doesn't.
What is it? I just hear,
So 3 doesn't go in.
how many times? So 3 cannot go in 206.
It can go in
So
68.
68, then you pick up the calculator, 68, 68.
68.666.
3 goes in here exactly.
Higher.
How do you know whether a number is divisible by 3? If you add the digits and the digits, it gives you a sum of a number that is a multiple of 3.
Even.
If you add here, you get good. So it's not going to be divisible exactly.
Yeah.
6 goes here, it might not go here. But let me ask, can 6 go in this number? 2 can go here, right? But can 3 go in this number?
Yeah.
The sum of the digits is 14. You're still going to calculate that?
It's not.
Come on, 8 plus 2 plus 4. So, we are going to have to divide
By 2.
by what?
2.
By 2. Okay? Negative 2. You don't have to do it, but you can do it. Okay? Even if you are here, you want to use the quadratic equation formula, it's fine. But we don't like this negative term here. So, we are going to divide here by negative 2, here by negative 2, and obviously that by negative 2. 2 into 6 gives you 3n squared. But now here's the thing. A positive and a negative gives you a negative answer. 103?
Yes.
N. A negative
Positive
and a
500.
negative gives you a positive.
574.
500
74.
Right.
Yes, it
Can we complete the square?
is. Yeah, no problem. Discriminant. So
What is our value of b? Is it necessary for me to put a minus?
no,
Okay, but I'm going to put it anyway, right?
special.
Since we are special, right?
Yes.
Okay. So please tell me, what is this answer? Your calculator can do this by itself. No? Just punch as it's there. Give me that answer.
Let's calculate this these days. You don't know. 3,721.
3,000.
721.
20.
Yeah.
Put that under the square root. Probably give you what? Some 31? 61. 61 times 61. Okay, anyway. N equals minus b plus or minus the square root of
61.
delta over 2a. Does that make sense?
I see, sir.
Good. So we know now the square root of this is giving me what?
61.
So I'm going to have the first answer will be minus what is my value of b? Negative 103. Let's do when it's plus.
60,
So 61 is there
Yes.
over 2 times what?
3.
3. Or n equals minus negative 103. Basically, it becomes a positive net.
I see.
Minus 61 over 2 times 3. So n equals to. You do understand the way the 61 comes from, right?
Yes, sir.
Therefore, the square root of 3, 7, 6, 2, 1 gives you that 61. Understand? So what is the first answer? What is 61 plus 103?
164.
And divide the answer by 6.
82 over 3.
30?
82.
32.
82.
80.
82.
Okay, that's some decimal. Let's look at the other one. What do you get here?
Let's see.
That is minus 61 plus 103. 103 minus 61. Say what?
97 over 6.
And you divide it by
Yeah.
6. And what do you get?
97 over 6.
You divided the answer by 6.
Yeah. Still gives you a positive. Subtracting from a negative side to getting
Let's repeat. What is 61 plus 103?
167.
167.
Yeah.
67.
64.
64!
60. I was there.
Now 164 divided by 6. You really get this? Okay. Let's go back here again.
Calculator's expression. So, why can't you believe that? 76, 97. Yes. Yeah? You go though?
Let's go again. Yeah, people are challenged here. Then, this answer should be a whole number, right? This is a positive 103. Hello? Positive 103.
Yeah.
Minus 61. Divide by 6.
How much?
Now, how much is it? You're sitting with the calculator and you're giving me funny answers. In fact, your calculator is of such nature that you can punch this in as it's there and it will give you the right answer.
7.
Yeah, one. So this one is invalid. So this is the answer. How many terms there?
So why is this one invalid?
Because how many kids are there in this class? Are there 8.8?
It's inequalities in the.
But do you see an inequality here?
I'm just saying.
But do you see an inequality here? Let's take them step by step. I didn't say that the sum is greater than or exceeds something by that. Alright? We are told that the sum is equal to that 501. So we have to work with the number that is. That is why I was saying in the beginning. Just because your equation is becoming quadratic, and most of the time, learners, they think that you will have a positive answer and a negative answer. But a positive answer and a negative answer comes from this side. If there is a minus here in front of the constant, then you will have a case where one answer will be positive and one answer will be negative. But here, in front of the quadratic equation, this was a positive side. So when you factorize, you're going to have two negative factors. And the roots, therefore, will be two positive answers. But you need to get a whole number because the number of terms can only be a whole number. You understand that? So yes, this is a positive answer because of the nature of the root. But it is not an answer that validates this because this says sum 82 over 3 position. What is that? Okay? The only time when we are dealing with decimals here is when we have inequality. We are told that the sum is exceeding by this or less than that or greater than that, which is fine. Is that fine? Mm-hmm. Okay. Did you finish writing down? You must tell me the time.
What?
Right now, 17, page 56. Read for me, please. The sum of the first 10 terms of what? Of an AP.
It's 210.
is 210.
And the sum.
I'm just going to separate it. The sum of the next
10
10 terms
is
is
610.
610. What are we supposed to find?
Common difference because A and
Common difference?
A and B.
And what?
First one.
So the first.
A and B.
And is there B part?
Yes, sir.
And what is the B part saying?
And the first three terms of the sequence.
Hence, find the first
Hence,
3 terms. Right. Let me just
emphasis.
give you the scenario. We're supposed to find the sum of the first 10 terms is equal to this. From term number 11 up to term number 20, you get 610. What will be the sum of 20 terms? You better be careful. Will you say, if the sum of the first 10 terms is equal to 210, and the sum of the next 10 terms is equal to 610, and 10, sorry. So if you add this 820, can you say that the sum of the 20 terms is 820? And if not, why is that the case? Okay, let me give you a very simple scenario because you have to create 2 equations here and solve them simultaneously. Because the moment you're supposed to find A and D, that should be the case. The moment you are adding it like that, you still have a problem. What is A and what is D? Do you follow? So now they're already telling you, no, this can be done like this. But let me just give you a very simple formula. So if this is an AP, and let's say the common difference is 2. Adding 2, you get 5, right? Adding another 2, you get what? 7. Can I start over? Right. Let's say that's the sum of the first 3 terms. Now what is the sum of the first 3 terms here? Still thinking? It's 15. Good. Now if I add 3 more terms there, are you with me? So after this comes what? Plus? Plus? I heard 14. Now the question says, this was the sum of the first 3 terms. Now if I take the sum of the next 3 terms, so I'm going to take the sum of this one, 43. Can you see that the sum of the next 3 terms is equal to 20 plus 13? 20 plus 13. Are you with me? What I was now asking, if you add the 15 here, okay, plus if you add this, is it going to equal to the same thing as 15 plus 33? Okay, 15 plus 33,
Yes.
that gives you? That gives you? Now let's go. I hope you're with me.
Yeah, I think.
Up to here is 15, eh?
Whoa.
What is 15 plus 9? It's not easy, eh?
That is.
What is 24 plus 11? What is 35 plus 13? You get the same. So what do you realize? If I say
If we add those ones,
210 plus 610 gives you what?
810.
Good. How many terms will they be?
20.
So we know our n.
20 is the.
Okay? Do we know our first term? So,
No, we have to
do we know our first term? Okay. Do we know our last term?
Yeah.
What is the last term?
810. No.
Well, this is sum.
You don't know. You don't know.
I'm talking about something like this.
That was just 8.
S of n equals n over 2
Like, go to our last number is 13.
Right. We don't know. That's what I'm talking about. Can we now say, okay, the sum of the 20 terms, because there are 20, right? Suppose this is the reasoning that someone is using. There's going to be 19D was now, no? Is equal to 820. You're going to have a little problem here. And your problem is that you are still going to have so I'll divide by 10. You're still going to have an A and a D there. You see that? And it's just one equation, and what do you now do? You need more information. Maybe you can bring in the 8th term.
The difference.
Or the last term. What is the last term going to be?
You just said it.
What is the last term?
We don't know the last.
Okay, but is it possible for us
These are them.
to calculate the last term?
These are them.
So how do you find the last term? You find the 20th term. What will be the 20th term? You see that? So there's more to do. So this is not a very good approach. So the way you do this one, because you have to create two simultaneous equations, is you go first up to the sum of the first 10. So first 10 is going to be there are 10, and then there's 2A which is not there, plus 9D. I hope you understand how 9 is there.
10 minus 1.
And the sum of the first 10 is equal to 210. Okay? Now this simplifies to nothing but, which is nothing but, and 5 goes there. Don't worry.
It's 10A.
41, 42 times.
So it's not 10A.
I am dividing 5 in there. Right? That's my first equation. Yes?
Simple.
Sum of the next. Here's the problem.
Next. Put next.
Why am I using the 20?
Because it's everything.
Because I can't start from 11. Do you understand what I'm saying? Because I don't know what 11 term is. Follow? So 2A plus
So we did it there.
800
We did it there.
800. So the formula becomes,
There.
that's our second equation. You see what 820 is important?